Good afternoon, my dear student. Today, I will discuss about population and population growth. First, what is population and population growth? Population is defined as it is a group of organisms of a particular species which breed among themselves or have the potential to do so and occupy a particular space. And population growth, it is the change of population strength per unit area per unit time. The population mainly depend on the birth rate, death rate, and immigration rate. Population growth or population strength can be explained by two mathematical equations. One is exponential growth model and another is logistic growth model. Now, we shall discuss about both the model elaborately. So number one model is exponential growth model. In this model, the birth rate and death rate are assumed to be fixed and the population grows steadily with time without any limits. In exponential growth model, the growth equation follow the first order rate equation and the general mathematical form of exponential growth model is this: nt is equal to n0 into 1 plus r to the power t, where tn and n0 are the amount or the population strength at time t and time 0, and r is the growth rate. The derivation of population growth model. Since we know that the population growth model for exponential model follow the first order rate kinetics, then the rate of change of population is written by the mathematical equation dn by dt is equal to r into n, where dn by dt is the rate of change of population per unit area per unit time. N is the population size and r is the rate of population growth or population growth rate. If we integrating this equation using the limits 0 to t, that means when t is equal to 0, then n is equal to n0, and when t is equal to t, then n is equal to nt, and after integrating we get ln nt by n0 is equal to rt, and after solving that this equation we get nt is equal to n0 into e to the power rt. So this is the exponential growth equations. So I repeat again up to this. So first of all, exponential growth model follow the first order rate kinetics, number one. Number two, in this model, it is assumed that the birth rate and death rate are to be same or fixed, and the population grows steadily with time without any limits. That is why this model cannot be used to calculate the growth rate of population in a city. Now we go to the diagram or growth rate curve. So this is the exponential population growth rate curve. If we plot the time in x-axis and if we plot the time population size, that is n, in y-axis, then we get an exponential curve, and that looks like a J-shaped curve. Next, since this model follow the first order rate kinetics, so there is a relationship with time and amount. So when the time will be double, then the quantity also twice its initial value. That means when t is equal to td, then nt is equal to twice n0, and put this value on the integrated equation, and we get t is equal to 1 by r ln nt by n0. And solving this equation, after putting the value of td and n0, we get td is equal to 0.693 by r. This is a factor, and where, and if we put the value of r in percentage, then td is equal to 70 by r percent. So when time is double, then the quantity also double, and the ultimate equation or ultimate relations with growth rate and time is td is equal to 70 by r percent. Similarly, for half-life population decay, if the population is decay means decrease, then the first order rate equation have a negative value. That means t is equal to minus 1 by r ln nt by n0. That negative sign indicates the population strength will be decreased. So if we put the value t is equal to t half and nt is equal to n0 by 2, then ultimately we get td is equal to 0.693 by r, or again td is equal to 70 by r percent. So these are the similar with the double timing. So I repeat again up to this. So first of all, or recapitulation of this today's class. First of all, what is population? Population is a group of organisms of a particular species which breed among themselves, or they have a potential to do so. And population growth, it is the change of population strength per unit area per unit time. And by help of two mathematical equation or mathematical model, that is exponential model or logistic growth model, we can explain the population growth in a city or in a town, etc. And now elaborately we learn about the exponential growth model, double timing, and half-life of the curve, and the shape of the curve is G-shape. So thank you everybody, and end of my today's lectures.